Hello dear students, previously we have discussed about the partial derivatives, but now we are going to discuss about application of the partial derivatives. So let us first understand first application of the partial derivative, maxima and minima. But already you are familiar with for a function of one variable, suppose you have given that for function of one variable, say f of x is equal to x square plus 4x. So in that case, what will be the maximum and minimum value? And for that, what we were doing, first derivative, so what it will be? So first derivative 4x plus 4. But here f dash x is equal 0, we need to consider to determine critical point. So here, whenever I assume that, so what we are going to get, 4x plus 4 is equal 0, x is equal minus 1. Now what I need to consider is first, second order derivative, so only 4. And at particular point x is equal minus 1, I just get the answer, that is the 0. That means the given function f of x have as minimum value at which one point x is equal, that is the minus 1, and that is already you are familiar with this. Suppose we have the answer f double dash at the particular point, say a, that is the negative. So what we can say, the function f of x has maximum value at which one point, at whatever the point is given. But if I talk about f double dash at a is equal 0, that means there is no conclusion. That means the function is neither maxima nor minima. So f double dash at a is equal 0. So we can say further investigation is required. But now we are going to extend this concept to function of two variables. So in that case, how we can determine extreme values of the given function, or you can say how we can determine maximum and minimum of the function at the particular point. So from the graphical representation, you can understand that, but when I consider highest of the all the local maximum, and that point is known as absolute maximum. But when I consider another, when I focus on this lower part, this one point, this is, and again this one. But you can understand that this one is what, that is the smallest one, and therefore this is what exactly absolute minimum, or you can say global minimum. Figure it is clear that this is our graph where you can see this is the largest one from the all the local maximum. So we can say this is the absolute maximum, and from the lower part we can see the absolute minimum is that. But what we can say about this one point, at this one point there is neither maxima nor minima, and that point is known as saddle point. So that from here you can see that this is what exactly our, this is neither maxima nor minima, and therefore this point is known as saddle point. But question arises, how we can determine this kind of points, and that procedure we have to follow. So here first we assume that u is equal f of xy, and we need to consider extreme value. We need to find your extreme values, that means maximum and minimum. So for that we need to consider p, q, r, s, t. But what about p? That is given function whatever it is, just do partial derivative with respect to x, then partial derivative with respect to y, so it will be the q, and r will be this 2 times partial derivative of the function f with respect to x, and then s is a partial derivative of the given function f with respect to x and y. Otherwise you may consider either order y and tan x, and it will be the same. And t is equal partial derivative of the function f with respect to y 2 times. But already you have determined fx, f sub y. So using this one you can determine r, s and t. And then now you have to take p is equal 0 and q is equal 0. And from this equation you can determine stationary point, or you can say the critical point AB. And at this point we will determine r, s and t, and after that we will discuss about the rt minus s square is positive or negative. If rt minus s square is positive and if r is greater than, so we can say function f of x has a maximum value at the particular point, say AB. But r is less than, but whenever we have rt minus s square is positive, so we can say function f of xy has the maximum value at the point AB. rt minus s square is negative, that means function attains both maximum and minimum value at that point. That means function doesn't have neither maxima nor minima. And rt minus s square is equal to 0, that means we can say that no conclusion can be drawn. For that, you have to read the further investigation. And let's have a look at the first question. Find maxima and minima of the function x cube plus 3 times xy square minus 3x square minus 3y square plus 7. So for that, what you have to do, you have to determine p, q, r, s, t. So let us first p, that is partial derivative of this function with respect to x. So I say this is f of xy. So what will be fx? That is 3x squared plus 3y squared minus 6x. And if I suppose to call q, that is partial derivative of the function f with respect to y, it is f sub y, that it will be, this is a constant because we are going to find partial derivative of function f with respect to y, keeping other variable constant. So this will be the 0, and here it will be 6 times xy, and this is the constant, so answer will be 0. This is the constant, so again 0. But here we can determine the minus 6y. Now, r, that means we need to consider partial derivative of this function with respect to x. So f sub x, that means 6x minus 6. As fxy, already fx, that is we have. Now we need to consider partial derivative of this function with respect to y. So we will get 6y, and after fyy, and that is called t. And what we are going to get, already fy is that, we need to consider again partial derivative of this function with respect to y. So what we are going to get, 6x minus 6. Now for the critical, or you can say for the stationary point, we need to consider p is equal 0 and q is equal 0. So this is p and this is q. But from this, what we can say, 6y common, so we get x minus 1 is equal 0. So from this, we can say y is equal 0 and x is equal 1. But when I put y is equal 0 and x is equal 0 in this equation, so we get the two different equations. So let us first consider this one case. So when I consider this one and y is equal 0, so it is going to be 0. So what we are going to get, 3 times x square minus 6x is equal 0. But when we simplify, so 3x common, so we will have x minus 2 is equal 0. What does it mean? This means this is equal 0, otherwise this is 0. So what we can say, x is equal 0, or we can say x is equal to. Now from this, what we can conclude, we have the 2 points because y coordinate is fixed and x coordinate is 0 and another is 2. So therefore we have these two stationary points. Now the similar argument we will apply for x is equal 1. If I take x is equal 1 and if I replace here, so what I will get, 3y square minus 3 is equal 0. 3 common and y square minus 1 is 0. Now we can divide by 3 and we get y is equal plus or minus 1. So what we are going to get, 2 points, 2 stationary points, x coordinate is a fixed and y coordinate is a plus 1 and a minus 1. And these are known as stationary points. So all over we have the stationary points 0, 0, 1, 1, 1, minus 1 and 2, 0. Now we need to consider r, s, t at particular point, this one, and after that we will decide that rt minus s square is positive or negative. So for our simplicity, I'm just going to consider this table. So let us see this table. These are the stationary points. So 0, 0, 2, 0, 1, 1 and 1, minus 1. And these are r, s and t. And this is whatever we have derived. And when I consider it 0, 0, so x coordinate is 0. So we are going to get r is equal minus 6. What about here? X is equal to, so 6 into 2 that is 12. 12 minus 6 is 6. And 1, 1, x coordinate is 1. So 6 minus 6 that is 0. 1, minus 1, x coordinate is 1. So again answer is 0. But what about for s? So when I consider all these stationary points, only I need to concentrate on y coordinate. So y is equal 0. So this is 0. Again this is 0. Here we have the 1 and then minus 1. So when I assume that y is equal 1, so s will be 6. And y is equal minus 1, so s will be minus 6. But what about t? But t is nothing but y, and that is 6x minus 6. But when I assume that x is equal 0, so I will get minus 6. X is equal to, that is 12 minus 6. So what I am just going to get? Only 6. And when I consider 1 point, so what I am just going to get? 0. And 1 minus 1, we will get t is equal, that is 0. But our target is to determine what is the sign of the rt minus s square. So r into t. That means we need to consider product of this one. So minus 6 into minus 6, that is plus 36. Minus s square, that is 0. That means we get 36, which is positive. And what about here? Whenever we get this quantity as a positive and r is also negative, that means according to our method, what we can say, the given function has the local maximum at point 0, 0. And therefore, if a maximum at 0, 0, the answer that is 7. But if I consider another point r, s and t is there, so I just take dot product of this one, that is the 36, minus s square, that is 0, that means it is a positive. And what about r? R is greater than, so what we can say, the given function f of x, y has local minimum. And what will be the local minimum? That is you can determine at the point 2, 0. So we can say f minimum at 2, 0. And that will be the what? Only answer, that is 3. But you need to verify that because 2, 0, where you have to put that? This is the our function and where you need to consider. So f2, 0. So whenever you put x is equal to, so we will get 8, this is going to be 0. 2 into 2, that is 4 into 3, that is 12. And this is 0 and that is plus 7. So you can see that 15 minus 12, that is going to be 3. So we get f2, 0. f2, 0 is nothing but 3. Now 1, 1. At 1, 1, r is equal 0, s is equal 6 and t is equal 6, 0. So what we are going to get? Dot product of these two, r into t, that is 0 minus s square, that is plus 36, but minus is there, so what we are going to get? Minus 36, and that is negative. And same argument at 1, minus 1, what we are going to get? Rt minus s square is negative, that means the point will be the saddle point. That means the function f of xy has neither maxima nor minima at this point. I hope that you have understood how we can determine maximum and minimum value of a function of two variables. Thank you.